Hello, I'm Andrew Fryer, and in part 4 of my Beyond Relational series, looking at FileTable, I'm going to look at using FileTable with a completely new feature in SQL Server, which is called Semantic Search. And this builds on top of the full text index and creates additional knowledge about what's in those full text indexes, as we'll see going through this demonstration. Before I can use Semantic Search, I need to do some installation work. I've got the installation media here for SQL Server Denali, and under the x64 directory in Setup we can see there is a semantic language database installer, and I'm just going to run that. Here I can choose where this database goes. You can go anywhere you like on disk, as with any other SQL Server database. That's finished, and now I need to go and actually attach it. The installation process doesn't do that for you. And here's the script to do that, although you can do this through the GUI from Databases and Attach. Interesting to see it upgrading the version as it was brought in. Now I need to run this special store procedure to register the database. And now when I refresh the list of databases here, we can see we have a Semantics DB database, which only seems to have one table in it and not much of anything else. And now I'm ready to modify a full text index for semantic search. And if you watched my last screencast, you'll have watched me set up full text searching on a file table here, and I went into the wizard, hit full text index and went through the wizard, and you can see the output of that here. What I didn't do last time was turn on these columns, and it wouldn't have worked without installing that database. And I could just check them here, and away I go. Further down here, I've got the code to do that. And you can see all we have to do is alter the index with this statistical semantics added on the end. I can check all of that's working okay with a number of DMVs which take as their argument the table being subjected to a full text index. This will show me the database ID, catalogue ID, all of which I could look up and turn into a nice shiny view if I wanted to. But I just wanted to check it's working okay. And while I'm here I can also just check and see how many items are in my full text catalogue. In this case 192, which corresponds to all the files in my file table. So now I'm ready to start using semantic search. The installation work I performed gives me 3 new functions, and I'm going to look at each one of these in turn. This first one is a table-based function called semantic key phrase table, and you can look all this up in books online. And what that does is return you a ranking score and a document key, and a couple of other columns as well. And I can then join that document key back to the unique key of my file table, which is always path locator, because remember, file tables have a fixed schema. And also remember that full text requires a unique key, so that's what we're leveraging here. That's how we're doing the join at the bottom end of this query. And then what we're doing is we're going in to the full text index and passing in the name of the table that's been subject to a full text index and the name of the column that's being indexed. And we're getting this ranking out. Now this could be done in full text at the moment. You could get a ranking back for a commonly occurring word. But when SQL Server Denali goes live, it's anticipated this will be expanded to a phrase-based search and will also include word stemming. So in my case, if I did this for cloudy as opposed to cloud, it would be treated as 2 different words, and we don't really want that. Ideally we want what's called word stemming enabled, where derivations of the word cloud are all included in the same term. Let's run that anyway. And it's no surprise that I've got lots of decks with quite high scores that mention cloud here, there and everywhere. After all, I work for Microsoft. So that's one of the key arguments. That's the one that's probably closest to full text searching. This is a bit more interesting. This uses a semantic similarity table based function. And what I'm able to do here is take as an example, a model if you will, one of my PowerPoint decks and find out other PowerPoint decks that are quite similar to it. And what I have to do first of all is turn the name of the deck into a unique ID for the row and then pass that into the similarity table. I can't do subqueries in here, the function won't let you do that. And then what I can do is get back a score and a name of all the other documents that are a bit like it and obviously rank them. So let's run that and see what happens. So these are the decks that are most like the deck I've just entered, and notice it doesn't return itself, it's quite smart like that. And it's no surprise that there's a deck there, the top scoring deck is very similar to the deck I put in, except that I had a version with some speaker notes in it that I didn't want to give to the audience, so I ripped a load of that out. But they're still sufficiently alike. The final function that you can use looks at two given files and tells you what they have in common with each other. Again, I have to pass in IDs, and that means that I have to pass in these path locator IDs, which are hierarchy IDs. So I declare them, look for my two decks, and then pass them into this function, and then it's going to return the key phrase and the key score in the top 10. And there we are. Now again, if this was properly done up with word stems and phrases, then this would be truly powerful, and I hope that's where we're going. So a lightning tour of semantic search, very easy to add on to full text search you already have, does need an extra database to store the statistics, and there are separate views in here to show you how large these indexes are and how large that database will get. I've been Andrew Fryer, thank you very much for listening.